this demonstration, you'll learn to create results objects in ANSYS AIM. You can create contours, isosurfaces, vectors, and streamlines to process numerical and graphical visualizations of your simulation physics. I'll use a wind turbine geometry to create results objects to visualize the interaction between the air and the wind turbine. For the solved structural simulation, I'll start by adding a predefined contour result to visualize the equivalent stress on the wind turbine due to the force of the wind acting on the blades. I'll right-click in the graphics viewer to create an equivalent stress result. The variable field in the property panel is already set to equivalent stress. I now have everything I need to create an equivalent stress contour, so I'll return to the task page and click Update. In the task page, I'll change the appearance of the contour by changing the coloring to smooth. This creates a smooth color transition for the contour plot, and also gives rounded numbers in legend ticks. For the equivalent stress plot, we can see that the stress is highest at the base of the tower, and it decreases as I move towards the blades. You can also see numerical values for the minimum, maximum, and average equivalent stress along the tower in the task page. In the graphics viewer, I'll right-click and select Animate to visualize the deformation of the wind turbine as a result of the equivalent stress. I can use vectors to see the direction and magnitude of the displacement of the wind turbine. I'll right-click in the graphics viewer to create a vector result. In the property panel, I'll select Displacement as my variable. In the task page, I'll change the appearance of the vector by selecting Smooth from the drop-down menu under Coloring. When I update the task page, I can see that the displacement is highest at the tip of the vertical blade. For a solved fluid simulation, I'll now create an isosurface to display surfaces of constant value for turbulence kinetic energy. I'll right-click in the graphics viewer and select Isosurfaces. In the property panel, I'll select Turbulence kinetic energy as my variable. When I update the task page, I can see the isosurfaces in the graphics viewer for the 5 turbulence kinetic energy values in the ISOValues field. To see air pressure in this region, I'll color the isosurface using a contour. I'll right-click in the graphics viewer and select Contour. In the property panel, I'll select Pressure as my variable. When I update the task page, I can see the isosurface colored by the air pressure downstream of the wind turbine. Now I'll create vectors to display the velocity of air around the wind turbine. I'll right-click in the graphics viewer and select Vector. In the property panel, I'll select Velocity as my variable. In the task page, I'll select Based on Mesh from the drop-down menu under Symbol Distribution, and enter 7 under Add Every Nth Item. When I update the task page, I can see the velocity vectors displayed on every 7th element around the wind turbine. Now I'll create streamlines to visualize the flow of air around the wind turbine. I'll right-click in the graphics viewer and select Streamlines. In the property panel, I'll enter 50 for approximate number of points. I'll select Inlet 1 from the drop-down menu for seed location. In the task page, I'll select Based on Mesh under Symbol Distribution and enter 3 for At Every Nth Item. When I update the task page, I can see the streamlines around the wind turbine starting from every 3rd element on the inlet boundary. I'll change the appearance of the streamlines by selecting Segments under Line Style. In the graphics viewer, I'll right-click and select Animate to visualize the flow of the segmented streamlines around the wind turbine blades. And that completes this demonstration of creating results objects in AIM.